So the Docker basics, we've all learned what Docker is. We've learned about its various components, its kind of key components such as images and containers. We went for a run, we ran through how to install Docker, the Docker registry, so Docker Hub, and what that's used for, storing images, etc., etc. And then we ran through some really kind of basic things to do with containers, such as exposing ports, mounting volumes, and linking containers. And that's pretty much where we got to. So in this advanced Docker workshop, we will be looking at some implementations of advanced containers. So we'll do that first. Then we'll have a look at Dockerfile, which is used to generate images themselves, not containers. And by the way, if anyone wants to refresh on difference between images and containers, just you can interrupt me and let me know. After the Dockerfile, we'll have a look at automated builds. So once you've actually got a Dockerfile in place, how can we automate a build of an image and how that integrates with a VCS implementation that we use. So the two main VCS, well, sorry, actually, it's not really VCS, it's Git integration. So how that integrates with either GitHub or Bitbucket. We'll then take a look at Docker Machine, and we've already seen the basics of what Docker Machine can do with creating Docker hosts for yourselves on local environments. So we'll see how we can use that further to create hosts on remote hosts. We'll also have a look at Docker Compose, which you can use to orchestrate containers. So where you actually have an environment consisting of 3 or 4 interlinked containers, instead of firing them up manually, you can use this to manage all of that for you. And we'll then have a really quick look at Docker Swarm. We'll go into a bit of depth on Docker security, and then the final presentation will be on what I think a possible Docker development workflow could look like for us. Okay? So, I hope I've got this in the right order. Okay. We're gonna go for the Dockerfile first. Okay?
Why not?
Why not?
Security at the end?
Yeah, security is definitely at the end. So, we will cover it though. So the Dockerfile, this provides a series of instructions to Docker so that it can build an image. Essentially, it's a very simple procedural script, and it contains successive commands which are run one after each other. They're executed in that order and that order alone, and they can be used to create a new image. So whereas we have an image which provides the template for a container, a Dockerfile you can think of as providing a template on how to build an image. Okay? So the great thing about a Dockerfile is that once it's in place, you know that your image is going to be built using that series of instructions, and you can see how your image has been built, what it consists of, and you can also put more trust in that image because you know exactly how it's been built. So the main Dockerfile commands that you will write as part of your Dockerfile scripting, you'll have from, and from sets the base image to use. So if you want to create an image based on Redis, then you could say from Redis. If you want to create something, I don't know, if you want to create a CentOS image which has got Vim on it, you can base it from CentOS. It sets the base image to use. If you want to set something completely from scratch, then you say from scratch. But you have to say scratch, but you would then have to compile whatever kernel base you wanted yourself. Okay.
So scratch doesn't give you blank; it gives you what?
It gives you nothing to work with. So.
Well, it gives you compile by sound.
I've never used it myself. I would advise that I would probably say that the only people who use Scratch are the people who are building the official repositories. What's up? Wow.
One doesn't taste nice. You have to put them together.
we got a double-decker sandwich going on here, made up of different stuff. Okay, so the maintainer command. Well, maintainer is there for you to reference who has actually built the Dockerfile and who's responsible for maintaining it. Run. This is essentially if you have a series of commands that you want to run. So you're basing your image from a CentOS image and you want to install Vim. You would say run yum install -y vim. Okay, so that's what run is for. CMD, this defines commands which are to be executed and essentially when the image is run, the very last thing that the image will do when it's put into a container will be the command that you specify here. So for example, if you're running an Apache container, your command might be HTTPD to start Apache. Or if you're running a MySQL container, your command might be MySQLd safe. Okay?
So what's the difference between run and command in this instance?
So run.
So if you can
run is not. So command is the thing that container should be doing, that image should be doing. So in other words, if you were building a MySQL image, you would run things like run yum install MySQL, run curl get me this particular configuration for MySQL or something like that.
Mm-hmm.
The CMD would be the actual start of the MySQL service.
But this can be done using run as well. Because you can run service MySQL
No, because
stuff.
the run is how you build.
Run is how you build it up.
It's all, and then the command is like hanging there, waiting for you to actually use it. And then when it loads that image up, you'll go right, and you run this command.
The image would depend on this command.
So it's something that can get executed essentially.
So it's the start command for that one.
Yeah.
Power it up.
So same with the entry point. This is almost always used as your specific service to enter a specific image or container. And generally it's used in conjunction with command. So what you would generally do is you'd specify the entry point actually as your MySQLd safe command. And within CMD, you would specify additional parameters for that to run on. So the config file, for example. Env is used to set environment variables for the image to work off. Workdir sets, when the image is being built, it sets the current working directory to be whatever you specify there. User sets the image from which all subsequent commands will run from. And expose and volume. Expose, by default within the image, if you specify a port to expose, then when you run that image into a container, that port will be available to all other images which link to it, all other containers which link to it. And same with the volume. So for example, if you were doing a MySQL image, you'd want to make sure you exposed port 3306. That doesn't mean that that port is going to be exposed to the host. It just means it's available to be exposed to other containers that link to it. And same with the volume. So if you specify var-lib MySQL, then it means other containers can actually access data on that. Add transfers data from your local host into the image. So for example, some of the ways I've used add, You can define a common my.cnf optimization file, which sits at the same level as your Dockerfile, and you can then copy that into this image when it's being built, and then use that when you fire up MySQL safe. So, Dockerfile best practices. So, containers that are created from the images, which are created from your Docker files, they should be ephemeral. And what we mean by that is that containers should be be able to be stopped and destroyed as easily as possible, and new containers should be able to be built with kind of absolute minimum setup. Okay, so there are some kind of special things you can do. Instead of executing a service, you might want to execute a bash shell script, for example, as your entry point or as your command that you run from an image. So an image can then execute something that you've defined, like run.sh, and that bash script could do things like git clone certain repository into it. It could, I don't know, install a PHP module. It could do a bunch of stuff. But at the end of the day, you want as much of that stuff to happen within the image build rather than on running of the image into the container. And at the end of the day as well, it means when you run containers from images, they will be a lot faster to run, because instead of having to wait for additional files to download, etc., the image has already got all that information and it can just fire up a container. Using a Docker ignore file, this is not something I've done, but essentially most of these best practices are ensuring that your image is built to the minimum possible viable image. Okay, so you don't want to bloat it out with unnecessary things. Bloating out an image increases the space and the size that an image takes, and that then means when you pull it down onto your machine, it just takes that extra little bit longer, and it means the image, well, it's best practice to keep those images as lightweight as possible. So for example, so using a Docker ignore file, you can actually ignore, you can only, it means when you actually build an image, you can get it to ignore certain files which are not applicable to the image itself. With the unnecessary packages, for example, if you're creating a MySQL service, it doesn't need a text editor as part of it, so don't install unnecessary packages, because again, it bloats the images. Run only one process per container, so that's kind of the whole Docker ethos, is in decoupling all of these services, and there are huge benefits to doing that. It allows for better scalability. It means you can horizontally scale just the bits that you want to scale, and it makes it easier to reuse containers as well. And it also makes it easier to upgrade containers to, for example, if you want to upgrade MySQL, instead of having to affect other areas of the code, you can just upgrade your specific Dockerfile which pertains to your MySQL service. So minimizing the number of layers and kind of sorting multi-line arguments. So essentially within each run command within a Dockerfile, and this will probably make more sense when we actually build one in a second, each command executes a new layer on top of your base image. Okay, so it actually, something which you probably might not see, but it actually builds up, each run command builds a new container. It applies the command that you've specified, saves that container, and then stops it and removes it. And then it goes on to the next one, and it takes that, that built-up container again and executes a new one, builds it up layer by layer by layer. So minimizing the number of layers and sorting multi-line arguments. So for example, if you're running, yum update, yum clean, curl this, etc., you can actually kind of write those as one command by doing a run, yum update, and yum this, and yum that, and kill this. So at the end of the day, you only end up having one layered image on top of your base image. So you should try and, this is really good practice to try and bear in mind and to, try and keep up when you're designing Docker files.
Does that mean basically that runs are a bad idea and we should try and do away?
Try and do...
Just minimise the number of runs we've got in there.
Yeah,
So
try and
just
minimise
get
them.
to 0.
It doesn't mean they're a bad thing. They're essential to building a Docker file. They're absolutely essential. And then the build cache. And the build cache is something which is always on. It means that, let's say, I don't know, you've got 2 Docker files, and both of them require a yum update, and they're both based from the same image. That yum update command, if you run it once, it will then get cached with a specific identity and a specific layer. And then if you run that on a second Docker file, it will use that cached layer to apply on top of itself. So it's something to be wary of. It's something which is used by default. To be honest with you, I've never had a problem with the build cache. Some people choose to disable it if they're having problems with it. So, demo time. Right, so what we're going to do now, and all of these demos are going to be kind of completely winging it, I'm afraid. But what I'm going to show you is how to build a basic image, and how I would go about constructing my Docker file. And okay, we're going to take a beanstalk service from a base CentOS. Okay, so we've got here our Docker machine environment running, and you can see I'm in my dev environment here. And I wonder if I've got some stuff running, but I'll just kill all of that very quickly. So now I've got no containers running. Okay, no containers running. So what I'm going to do, I'm going to go to Docker, Docker WS. I'm going to make a new directory called Docker Beanstalk Composer. No, we're not doing Composer, we're doing Dockerfile. So in fact, I'll just call it Dockerfile Beanstalk. I'll go into that, and I will create a new Docker file. Okay? Now, in this Docker file, and I'm just going to bring up this one as well. Okay, so very first command you always write in a Docker file is from. So here we're going to say from CentOS 6, okay? And then I'm going to say maintainer, it doesn't matter who it is, Dave, DSW, Dave. You can put your email address in there. It's literally just a reference point. So that's my Docker file. It's pretty basic to begin with. And if I run this, can anyone tell me what's going to happen?
Nothing.
A CentOS.
Correct. I'll get a CentOS system. So here, if I just show you, I've got my Docker file now. It looks like that. To build a Docker file, so you can just have a look at my images. Okay. So I'm going to build this Docker file, and to build it, use the docker build command. Okay. -t allows you to specify a name for the image, and we're going to call it something which I've not got there. So someone put your hand up. Anyone?
Potter.
Potter. Okay. We'll call it Potter, and we'll call it just Potter CentOS test. Okay. And then you have to specify a dot, and that dot tells Docker build that the Docker file it's going to use is in the current working directory. If you want, you can specify a particular path to your Docker file. Let's embarrassing.
Your Dockerfile. Capital F is capitalized on the F is capitalized.
Yes. Okay. Thank you. So, everyone note, Docker files, format, capital D, nothing else. So, that was pretty quick, wasn't it? And now if we have a look at my images, you'll see I've got my new Potter CentOS test image right there. And if I run that, it was about an hour ago. Yeah. Well, spot
It will
it.
take an hour.
There, so now I've run bash inside that new image that I've built, and if I have a look, I can prove that it's a CentOS 6.6 image. Okay? So then, actually, let me bring that one here. So the kind of things I would then do once I've got my base image up and running like this, I'd then kind of think to myself, okay, what do I want this image to be a service for? What kind of commands would I run in this particular image to get the thing that I wanted? So we're going to install Beanstalk. Okay, so some of the things I might do, I might change directory to the temp directory. I might do a yum-y update, and that's going to obviously update my repository manager here. And for Beanstalk, you actually have to use curl and make to compile it. So I'm then going to install the necessary things for that. So I've just done a yum update. Oh my god. That's 6 of 108. They go pretty quickly, don't they? Everyone have a bite of your sandwiches. Thanks, me. Ah. Okay. So then, to install Beanstalk, you'd maybe consult the manual and you'd say, right, do yum install. What do we need? From scratch CentOS, we need make. We need these things. I know that because I've got it right here. Kind of cheating. And hey, stop cheating. Okay, and then what we can do, and I'm going to copy this from here, but you can see this is my Dockerfile. This is the actual Beanstalk tar. So that's the Beanstalk tar. We're going to do a wget on that. We're going to cd. We're going to unzip it, untar it. So that's a tar extract of that. And then we're going to cd into Beanstalk, and then we're going to do make. We're going to make install. And then look, we got Beanstalk. Which Beanstalk D? Oh, I don't have which. Anyhow, if I run Beanstalk D, there, it's actually up and running. And if I can prove that to you guys as well. So we've got a container which has been up for 3 minutes, which is our Potter one. I can log into it as a new terminal instance. And if I do a psef grep Beanstalk, there we can see our Beanstalk service is running. Okay, so those are the kind of things you do to set up a Beanstalk service. But we want to fully automate this, don't we? So that's what you do in your Dockerfile. So yeah, in your Dockerfile. So if I exit that and exit this, and I'm just going to stop my containers and remove them. So first thing we did there, we did a run cd temp. Yeah, that was it. And now we're going to do the bit where I said about sorting line arguments. So yeah, we could do run this. We could do run yum-y update. But at the end of the day, that's going to create multiple layers. So instead of doing that, we can do this. And again, what else did we do? We did a yum -y install tar tcl gcc make. You don't remember any others? wget. Thanks.
Which?
Okay. Yeah, no, we'll stick which in there. And then we did an and we did this wget, and then I forgot to do the tar, didn't I? So we'll do the tar xzvf of that very specific. Yeah, this.
Would have been easier to copy the commands while you're typing them.
That's what you can do a history.
I was going to say, we use it.
Yeah, right.
You need to
make sure there's no history.
Because you blew the machine away afterwards.
And then we did an and make, and then we did an and make install, and okay, we'll just leave it like that. So we'll finish it there, and we'll see what happens. Okay. So that's our new Docker file. So Docker, I'll remove that. So if we have a look and see what images we've got still got the Potter CentOS test. What?
What?
Oh.
Oh, I hope no, way.
Okay. So to remove an image, Docker RMI and then the image ID. Okay. So we don't have a Potter image anymore.
Oh.
Okay, but now we've got our Docker file which has got all of those commands in them. So we need to rebuild it again. Okay. So Docker build. Someone put their hand up.
Potter's good.
All right. So we're going to tag this now since we're using the same Potter. So we're going to call this 1.1. Yeah. And you can see in the output here, you can see it's going through and it's doing everything that we just did manually. Okay? Yeah, that's good. So there's our yum update going through with 108. Seem to remember at about 70 it's sped right up, isn't it? Okay, fine. So generally, what I found. So we've got Docker images. We've got our Potter CentOS 1.1 now, right here. Okay. So now I'm just gonna do my Docker run of 1.1, and which should work now because we've installed it. There we go. We got beanstalk D automatically installed for us. Everything that we've set out. Okay, and then to run it, you do that. Okay, so we're going to go back and we're going to go make some more changes to the Docker file. And this should hopefully allow you to see what entry point and CMD and stuff like that is useful. So we can then say, right, I know that beanstalk runs on port, anyone? Quite a big one. So I'm going to expose port 11300 by default.
Was it?
Hmm? Yeah.
That is red. Yeah. That's close to red. Yeah.
And I'm going to say
6379.
Yeah.
my entry point is going to be what? User local bin beanstalk D. We'll specify the full path just to be absolutely sure. Okay. Other things we could do here. I just want to show you guys. So other things we could do, and I'm gonna not do them here because it might take a bit of time, but So for example, we've got a Dockerfile here where we actually copy. So you can see we've got the copy command, and we copy from our source directory here, we copy some of these things into the image as it's being built. So this means that anything in the, all of these configs here, maybe our flat URLs, we want to make sure that the image knows about all of them, so that depending on whether we're putting a kitty care site up or a Casfina site up, it can actually switch between the flat URLs and so on. So it is pretty much the same as add. Yes, just leave it at that. Add and copy, yeah, are the same, but they're not. But they are.
Copy is copy.
And you can see here, this is quite interesting as well, because instead of saying our entry point is an actual, this is for our SKU-based one, instead of saying our entry point is for an actual service which can run, we're saying actually, it's for this run shell script, which I'm going to copy into the image, and then when you execute the image into a container, when you run it, it will then go through and execute the shell script as its entry point. Okay. Anyhow.
Why didn't you just put the things there?
Because
That's a Dockerfile.
So you can see here within this specific shell script, we are actually making sure that we set our application environment to be whatever is in the environment variable set, and we can change this when we run an image. Same with enable xdebug. These are the kind of things that we can affect when we run an image into a container at runtime by using this kind of approach. Whereas if you just said entry point is HTTPD demonized but running in the foreground, if you said that's your entry point, then that's literally all. When you run the container, that's what would happen.
if you put those in the Dockerfile, then it will look for those environment variables at build time only. And so then when other people are running it, they're not going to be able to use those environment.
Okay. So if we go back to our default, we now put this entry point as beanstalk D. So I will build Potter 1.2. And did you see how quick that was now?
Oh, just put a tone on top.
Because we've got our layered system, where all of those bits have been layered, the yum, y update, everything else, that was just incredibly fast to build our subsequent image. Okay? Because of the build cache. Sorry?
There is a mention for using cache.
There's a mention.
Below step 1.
Yes.
Using cache.
Using cache, yeah.
And then running.
And then running. So these were the new bits. And these are really, really quick things to do. So you'll be able to see now, if I do a Docker run, this time I'm going to say, right, I just want to set the process running in the background of whatever the image does. I'm not going to log into a bash script or anything like that. So I'm going to do a Docker run of, what do we call it, Potter test. Is it? Okay, here we go. So we'll do the 1.1 first, which doesn't have the expose or the entry point. So docker run -d Potter CentOS test 1.1. Oh, crap. Thanks, peeps. Okay, so now this container will have bombed out, hopefully, which it has. You can see this was the one we just exited 3 seconds ago. Reason why it bombed out, it doesn't have an entry point, it doesn't know what it's doing. You fire it up, it goes, I've been fired up, that's great. I've got no other purpose for being active, so it shuts itself down. If we do this with 1.2, we set the entry point as being the beanstalk D service, which is running in the foreground. And if we set that going, you can see it's up, and it'll stay up as long as that beanstalk D service is running in that container. Okay, so that's kind of a quick overview of Docker files, and we will be coming back to them later on in the workshop. Does anyone have any questions on them? No? Great. Okay, back to Keynote. So, advanced Docker containers. So we're going to really briefly cover the Nginx reverse proxy, the composer bower, and then we'll go into a bit more detail on data-only containers because I think they're really important and I've used them a lot. So the Nginx reverse proxy. This is something which is there to ease the setup of our development environment. If you cast your mind back to the basics workshop, we kind of finished that off by setting up an Apache container, which we then had to access by in the browser by going into the Docker machine's IP and putting a colon 8080 of whatever port we bound. We did that for the Beanstalk console. Okay, that's a bit of a pain in the butt, really, and is not something manageable, especially if we want to use this fluidly within our own local environments and on our test environments. So we've got the Nginx reverse proxy to sort that out for us. What it is, it's an image which is based on an Nginx, standard Nginx image, which does the reverse proxying for us, and something called Dockergen. And Dockergen's a really clever image built by a guy called Jay Wilder, and what that does is we bind the Docker socket into this image when we run it. So that means the Dockergen image has got full access to see what containers are currently running. And it analyzes the containers as they're run, as they're started. And if you pass in a special environment variable, this virtual host environment variable, then it picks that up and it analyzes the actual container that environment variable has been set for. It gets the IP address of that container, and it then passes all that information to a template scheme, which we can define. So the template scheme's done using the Go template lang, which is not great. I don't know if has anyone got experience using it? No? Okay, it's a bit of a biatch. But using that template, it can then generate configuration files for Nginx, which Nginx can then use to drive its proxy forwarding. So if we bind this image to port 8080 and 443, means that anything coming into that Docker host now, anything HTTP or HTTPS will go through this reverse proxy container. Okay? This reverse proxy container will then be able to forward the requests to the appropriate front-end containers that you've got set up. So, you still have to set up your DNS to point to whatever host you're running it on. That's quite an easy thing. Obviously, if we're doing it locally, you just set your etc host file to point to the Docker machine. If we're doing it on a test environment, yeah, we'd probably have to set up a DNS entry for you in DNS Made Easy so that the entire company can use it. But again, we've got an alternative to make that even easier for you guys. So, does anyone have any? Does that kind of make sense to people? Do people see why we might use that? So, for example, if I set up the Beanstalk, so we'll use the Beanstalk console, which we used in the last at the end of the last workshop. Instead of saying Docker run my Beanstalk D console, bind to port 8080. And then you can access that in the browser by going to your Docker machine IP address, port 8080 in the Docker browser. That's one way of doing it. Or you could have said docker run -e virtual host dev.beanstalk.d and then the Beanstalk D container. And that virtual host dev.beanstalk.d would be picked up by this reverse proxy. Then when you put dev.beanstalk.d into your browser, the request would be made here. This container would forward the request to your Beanstalk D console. And as long as you had a host entry saying dev.beanstalk.d points to this entire Docker host here, then you'd be okay. We'll do some examples of this to make it even clearer. Okay. So Composer and Bower, these are some things which I had to do a bit of research and I created our own images for these. But essentially, if you've got a brand new laptop like this, you don't have Composer installed on it. You don't even have PHP installed on it. And you certainly don't have Node.js or NPM or anything like that. So, fine, we can do a git clone of our code down onto the machine, but then you're a bit stuffed if you actually want to install, your dependencies. But we can do that straight through Docker. So we'll maybe have a look at the Docker files for these images that I've created, but essentially the command for Composer, forget the SSH keys at the moment. You've got a docker run --rm. --rm removes the container when it's finished its work. And then we're going to say, right, let's say I've got my David Ward site Cubase app, which has got no vendor directory, but it's got a Composer JSON in it. So I'm going to mount that directory into app of the image, app of the container, and then I'm going to run Composer install and ignore platform recs. And that will immediately be able to, because this image has been built with Composer and it's got PHP and all the necessary things to run Composer, it will be able to install your dependencies for you. Same, pretty much exactly the same with Bower. And again, I will, in fact, why don't we just have a look at these right now. Let's go to test. Ooh. Let's create a Composer JSON. In fact, let's see something else. So Docker images. Okay, so I've already built the world source Composer image. And if you guys want to see what that looks like, I think it's this one here. So you can see it's a really simple image. It's from Debian. It doesn't matter what we use for this. Debian is easier generally than CentOS. Ubuntu is. So we'll do an apt get update. We will install PHP 5 on it. We'll get Composer, get that installed, and we'll say that our volume is app. Okay, so this is going to be the working directory. So when we fire that image into a container, that is what it's going to execute commands on. Okay, and we're going to say our entry point is the Composer file. Okay, we also add the Composer user to run the Composer commands instead of running it as root. Okay. So once that is built, I can then, so I'm in test, I can then use it. I can say docker run, let's say --rm so it doesn't build up. And I'm going to say world stores /composer. And I'm going to, you can say Composer require, and we'll just do a new, one of the things I need to prove to you first, obviously. I don't have Composer running on my machine, okay? So Redis, I think is, or is it Predis? It's Predis, isn't it? Okay. Is that going to work? World stores Composer. What have I left out? What have I left out here? Okay, so I haven't mounted any apps into it yet either. Woohoo! Okay, so I think the problem was there that I didn't mount the current working directory in, so it didn't actually know where to. It didn't have any place to install the Composer files, possibly. But you can see there, I've now got a vendor directory. Yeah.
Is that the only use case for having this Docker machine?
For having, oh no, this has got nothing to do with Docker machine.
No, so you said because you don't have Composer installed on your machine, you created this Docker in order to run Composer without installing it.
Yeah.
Is that the only use case?
For this specific image, for this Composer image,
For this composer.
Yeah, the composer image is only there to run composer commands.
Why not just adding run composer install or installing composer in each Docker that you are going to have?
On each Docker host,
Yeah.
because you're building up unnecessary layers, aren't you?
How often do you use composer?
It's well all the time. But the point is with Docker, you want to have individual. It's okay. It might be
Because you are
overkill.
going to run on a dependency or something related to that.
It might be overkill, but it's an example of showing you guys how to do this without actually, you don't have to, if you've got Composer as a dependency for your Apache projects or some of your PHP projects, you don't have to install it as part of the same image. You don't have to have those things coupled together.
Yeah, but you need to run 2 images in order to do one thing.
No, because that image runs and then.
And then that's it. Yeah, it's literally it's a one-off file. So let's say you manage this through something like Rocketeer, for example.
Mm-hmm.
Instead of Rocketeer logging into the container and running Composer install, you get Rocketeer to use this image, which this image is there to run Composer, and you kind of know that it will do that very well, and you can manage the Composer versioning through it, for example. Instead of managing 6 or 7 different installs of Composer, you just have one place to manage it. Okay.
And if you've got a standard setting, any standard settings you want, and that's a centrally accessible.
No, but let's say you install it. Let's say you have 5 or 6 Cubase, 5 or 6 project images, and each one of those has Composer installed on it. You build those images once. Composer's at a certain level, right? If Composer gets updated the whole time, you'd either have to do a Composer self-update on all of them, or rebuild those images again with the latest version of Composer.
But you'll do that anyway, even with that machine.
That's fine. This is the way I would do it.
Okay.
But you guys are free to obviously manage images in whatever way you feel is best for you. Okay? It's just all I'm trying to say from this is it's not a problem having these kind of things decoupled.
Yeah. What you're actually saying is that you can use a Docker image as a utility that will then do a whole series of stuff to your
possibly
own drives.
Yeah, and so I've seen instances where people have created they've created images and containers where you can actually they've created aliases for pumping in git flow commands, for example. So instead of doing a whole git flow stuff individually, they can use Docker to actually send through commands to your actual container, and then it'll execute a series of instructions.
I guess this is more important when you start thinking about Docker machine creating remote instances, because most of us have got Composer on our local kit, and we can just run it against the mounted volume. But when that mounted volume is up on a droplet somewhere in the cloud, then you can just.
So how about Composer cache in this case? So when you run Composer on your own local machine, for example, or maybe on your image, you'll have everything cached in that machine. When you run it from a Docker, where does the cache reside in this case?
If you're running inside the volume, the cache is running a lot file.
It's 2:30 already, guys. I'm not even like.
Are we not going to get to?
What?
We may wait. Okay, let me finish off with data-only containers. And we may have to split this out into another session next week.
You can do it on your own and send us that recording.
Wow, and I thought.
It works on the same principle as Docker. We just fire it up and use it.
Yeah, it's worse.
Okay.
Let's go to it quickly.
So data-only containers. So one of the things that we've seen that we're able to do is mount volumes into containers. So for example, MySQL, you could have your actual data volumes sitting on your local machine, and you can actually mount them into your MySQL service container in order for it to use the MySQL data that you've got in your local machine. Or if you've got an Apache PHP image, you could have code sitting on your local machine, mount that into your Apache PHP image, and it will use that to run on the web server. Okay. One of the kind of disadvantages about that is portability primarily. So if you've got a database, for our example, we've got loads of different websites, and you want to really quickly fire up a MySQL service for, let's say, KittyCare or Casfina or something like that, you would have to either MySQL import that data into the service container from a dump, which is generally what people are doing right now to set up test environments. You've got a MySQL database running, and you create a new database, you get a backup from somewhere, you do a MySQL import into it, right? The other way you probably wouldn't ever have those MySQL files sitting on your local machine to import, but you could do to actually do that. With data-only containers, what you're doing is you're kind of taking the decoupling level to a decoupling process of Docker to another level. You're decoupling your data into one container, and then you are firing up your MySQL service, which can then use the data from one container as its source. So, yeah, for me, the main benefit of this is portability. It means that we can fire up data-only containers for a KittyCare database, for example. We can zip those up easily, compress those. We can give them to one another with, very, very much. That doesn't really make sense. We can give them to people in a very fast way. So we can stick them onto a USB drive, something like that. Give them to a person. They can then unzip that into a new data-only container. It's much faster than doing MySQL import, way, way faster. So it means we can get our dev environments up in no time at all. And it means that if you actually had your data in your MySQL container, you're actually then introducing stuff that service container doesn't really need to know about into it.
Isn't this main of great use to QA with regards to it allows you to reset to previous conditions so that when you're doing your tests, you're working from the same place all the time as opposed to working from wherever you went to last time?
There's that, and there's also the added benefit that you know that whatever you've developed on locally is going to be literally identical, even from a data perspective. So not just the same MySQL version running. You know that when you put something over from dev into test, it's going to be exactly the same as what you've developed locally on, as what they're going to develop test on. So using data-only containers, I've given an example here of a web app. So you can create a data-only container from anything, really, from any image. And by default, this world stores SKU-base image. It's got an entry point of, I'll show you, I believe, well, it's that run sh script we saw. And the run sh script fires the httpd-d foreground. Okay? So by default, if I was just to start up this image, that is the entry point that the container would use when it's fired up. What I'm doing here is I'm overriding that by saying I want my entry point just to be an echo, and then this is the command that it runs. So it's going to echo data-only container for web app. We could use a bare bones image, something like BusyBox, which is a 3 megabyte image, very, very small. And if we actually have a look at this SKU-base image, it's actually Docker images. So I'm just going to do a Docker pull of BusyBox. This is just a really, really light bare bones image that does nothing. So you can see BusyBox is down here, it's 2.43 megs. And world stores SKU-base here is 418 megs. So why would we use the SKU-base image instead of the BusyBox image, when all we're doing is putting some volume files on the image itself. Exactly. So the reason is because of all that layering. So because we're going to be using this SKU-based image anyway to fire up our Apache PHP instance, it's already going to exist. And because of the way Docker works, we are going to consume precisely 0 megabytes extra by firing up another container of this. If we fired up a BusyBox container, we'd use 2.433 megs. So that's really kind of getting into the nitty-gritties of it. Feel free to use a BusyBox instance if you want, but this is kind of best practices for Docker as well. So one of the things I'm going to show you then very quickly before we leave is, well, I'll run through the rest of this slide very quickly. So we've got the creation of it, where we say, okay, I've already done a git clone of, I don't know, our SKU-based repository into my site SKU-base. I'm going to mount that into var www SKU-base of the world source SKU-base container, and that's all we're going to do. We're going to bomb out the container after that, because it's going to echo data-only container for web app. It'll have done what it needs to do, and it'll stop. But that data will still exist in this container. And then, to use it, we'd say docker run -- volumes from web data. So this is going to be our actual web app container, which is going to run world source SKU-base, and this is going to run Apache now because we've not overridden the entry point or anything like that. And it will use the data found in this container to run itself. Very simple. To back it up, this is possibly a little bit complicated to begin with, but it's actually very simple. Forget about this use query that we've just run, and just imagine that we've got our web data container sitting here. What we're going to do is we're going to say, with the volumes from web data, I am going to essentially tar compress up var www SKU-base into backup webdata.tar on the container. But we need a way to get this backup webdata.tar back to our host, and that's why we mount our current working directory or any directory on your host that you want into backup. So as soon as I run this command, it will then do a tar compression.
Do you know how much? Because I booked this for half past.
Yeah, it will be like 5 minutes.
Oh, okay,
yeah. And then to restore it again, it's pretty much a similar command. You're saying volumes from web data, and you're extracting your webdata.tar, which would be on your local host in your current working directory there. Okay, so what I'll do really, really quickly is just show you guys how this might work for, I think have I got world source MySQL there? Nope. So I'm going to do this for a database. So I'm just going to pull down MySQL, hopefully very, very quickly. Whilst I'm doing that, I think I've also got a previously backed up MySQL database from KittyCat. And if we go into, I really hope I've got one. KittyCat, yes. Okay, so I've got my MySQL data there. And you can see I've actually got data zipped up data-only containers for all of our main services there. That's got code in it. The Redis data's got the .dump for Redis in it, and the MySQL data's got the varlib MySQL stuff in it.
These are not containers, just data.
These are not containers, no. Okay, so we're waiting for this, but once that's finished, I'm going to run my data-only container. And if you're ever in doubt of what commands you should be running, always start with the basics. So docker run and then your image, and then flesh it out from there. So think, right, I am going to be setting the entry point to be bin echo. And I'm going to make the command doc echo data only container. And Yeah, I can set a name for it. And that's it, actually, isn't it? So I'm going to say KC MySQL data. Okay, so it echoed out DAC. If we have a look, we can see it's exited. It's got nothing there. Within the actual world source MySQL image itself, in the Dockerfile, we had a volume varlib MySQL stated there. So that means varlib MySQL is now available to other containers. If you didn't have that, you would have to, when you specified this, you would have to specify -v varlib MySQL to have the same effect. Okay. So now that we've got our data-only container waiting for us, PA, it's this one, KC MySQL. I'm going to say docker run --remove --volumes from KC MySQL data, and I'm going to use a shitty image like BusyBox because this is going to get removed. It doesn't matter what we use for this really. It's just got to be something which has got the tar capability. Okay, and then the command I'm going to run. Oh, firstly, I'm going to mount in my current directory. So it's going to be print working directory. I'm going to mount that into backup. And then we're going to say BusyBox tar extract. And I think it's just VF because of the way I've created this, because I didn't do it with gzip. So tar xvf, and it's going to be backup, and then if we have a look here, it's going to be MySQL data.tar. Okay.
It's because you've got.
Yeah, dash. Ah, I
Put it in between.
screwed up there. Okay, KC MySQL data. Okay, and you can see, hopefully here, you can see, look, this is everything from the tar file. These are all of the files used by MySQL to generate its database. So this is extracting it all, a full KiddieCare database into that data-only container. And we'll see how long it takes. But I mean, imagine if you did a MySQL import on this. That would take, I don't know, at least half an hour for something like KiddieCare. With world stores, it would take, yeah, a couple of days, something like that.
And this takes, I did a whole central admin, 15 minutes, just the time that it takes to tar 35.
Yeah. So that's it done and dusted. If I fire up docker run -d world stores MySQL, just to show you what's going to happen, there's no volumes from on this. Okay. So if I then connect to this MySQL-u admin-p world, I've spelled that wrong. Crap. Okay. There won't be any databases here because it's completely fresh. We didn't say volumes from anything. Okay? Nothing there apart from the standard install ones. If I then run that exact command again, but I specify volumes from, and we say KC MySQL data, and I run that, and we'll do the same thing here, 751. Show databases. This is a brand new service now. We've now got KiddieCare there. We use KiddieCare. Show tables. Boom. Everything. So that's the power of data-only containers, and we will move on to automated. No, we'll do another session next week. We're planning on having a week's gap anyway, I think. But I hope you guys have found that interesting.